Welcome to our YouTube channel AKN Sprint Education. Myself Naveen, I am the Maths Mentor. Students, today's session let us discuss the glance introduction about probability. So what do you mean by probability? And the key concepts behind this chapter, also the concept of set of chords we'll discuss in this chapter. Probability. The probability of an event E is denoted by P of E and it is defined as P of E equal to number of outcomes favorable to E to the number of possible outcomes. The probability is nothing but it is uncertainty. We can also call it as randomness. Okay. The formula for probability is number of outcomes favorable to E to the number of possible outcomes. Now coming to sample space, the set of all possible outcomes of an experiment are called a sample space. Also we call it as probability space. For example, if a coin is tossed, either you may get head or tail. So what is the sample space? Sample space, it is denoted by letter S equal to head and tail. For example, if a die is thrown once, what are the possible outcomes? That is 1, 2, 3, 4, 5, 6. That is the sample space. For example, when a coin and die are tossed together and the corresponding sample space for the random experiment is either you may get head 1, head 2, head 3, head 4, head 5, head 6 or tail 1, tail 2, tail 3, tail 4, tail 5 and T6, right? Now let us see what is the meaning of event and outcome. An outcome is a result of random experiment. Now coming to what is the example of an outcome. For example, when we roll a dice, getting 6 is an outcome. An event is a set of outcomes. That is the difference between event and outcome. An outcome is a result of random experiment. An event is a set of outcomes. For example, when we roll a dice, the probability of getting number less than 5 is an event. An event can have a single outcome also. Now, what do you mean by random experiment? In an experiment, we can expect outcomes but not result. That experiment is called as random experiment. Tossing a coin is a random experiment. In this experiment, we can expect outcomes, that is head or tail, but not result. That is said to be random experiment. Throwing a die is a random experiment. Now, what do you mean by elementary event? If an event has only one possible outcome, then it is called an elementary event. If a die is rolled once, 1, 2, 3, 4, 5, 6 are elementary events. The sum of the probabilities of all the elementary events of an experiment is 1. Now coming to equally likely outcomes. If we have the same possibility of getting each outcome, then it is called equally likely outcomes. A dice have the same possibility of getting 1, 2, 3, 4, 5 and 6. Not equally likely outcomes. If we do not have the same possibility of getting each outcome, then it is said to be not equally likely outcome. 3 green balls and 2 pink balls are not equally likely, as the probability of green ball is 3 by 5 and the possibility of pink ball is 2 by 5. Now, what do you mean by sure event? also we call as certain event. If the probability of an event, if the possibility of an event to occur is sure, then it is said to be the sure event. Here the probability is 1. Example, if we throw a dice, the event of getting a natural number less than 7, obviously 1, 2, 3, 4, 5, 6 are less than 7 only. That is called sure event. Now coming to impossible event, if there is no possibility of an event to occur, then its probability is 0. This is known as an impossible event. If it is not possible to draw a green ball from a group of blue balls, obviously we can't draw green balls from the group of blue balls. That is an impossible event. Now coming to mutually exclusive events. Two or more events are mutually exclusive if the occurrence of each event prevents the every other event. When a coin is tossing, getting a head and getting a tail are mutually exclusive events. Now, exhaustive events. When a sample space is distributed down into some mutually exclusive events such that their union forms the sample space itself, such events are called exhaustive events. Or when two or more events form the sample space collectively, then it is known as collectively exhaustive events. Or when at least one of the events occur compulsory from the list of events, then it is also known as exhaustive events. Example, a sample space is given s equal to 1 to 10. To understand what exhaustive events are, let event x is 1, 2, 3, y is 4, 5, 6, z is 7, 8, 9. Event x, y, z are mutually exclusive because if you observe here, x, y and z whose intersection is pi. Now check whether the events are exhaustive events or not. For this, take the union of all the sets, x union, y union, z. Again you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is S you got, sample space. Then x, y, z are exhaustive events because they form a complete sample space itself. That is the example 1. I mean the union of all the events which gives the sample space. That type of events are called exhaustive events. You can see example 2 also. A coin is tossed. Tell whether the events are exhaustive events or not. Suppose event x is heads will appear, y is tail will appear. Both events together are exhaustive events because one will occur during the conduct of an experiment. Now range of probability of an event. The range of probability of an event lies between 0 and 1, inclusive of 0 and 1, that is probability of an event which lies between 0 and 1. Complementary events. If E is an event, then the set E of all outcomes which are against to E is called its complementary event. The probability of getting a white ball from a bag of ball is 1 by 4. Then what is the probability of not getting a white ball? That is 1 minus P of E. 1 minus 1 by 4, that implies 3 by 4. Now coming to a deck of cards. It has 52 cards. There are 26 red in color, 26 are black in color. Again red colors cards are divided into 2 shoots. Each suit of consists of 13 cards. They are diamonds and hearts. Again black cards 26, they are divided into 2 shoots, 13 cards each, that is spade and clubs. So here again each suit consists of 13 cards. They are jack, ace, king, queen, jack, number 10 to 9. A jack, queen, king are called face cards. In each suit we have 3 face cards. Totally 4 suits, 4 into 3, 12 face cards. And what about non-face cards? 52 minus 12, that implies 40. You can see here arrangement of cards as here ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. There are totally 4 suits. The first one is clubs, second one is diamond, third one is heart, and fourth one is spade. So as spades and clubs are black in color, diamond and hearts are red in color. So here you can see Jack, Queen, King. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They are called face cards. Remaining all are non-face cards. We have 6 red face cards and 6 black face cards as well as. So this is about face cards. So this is about introduction of the chapter probability. The thing is you need to understand the concept so that you can do it the problems easily, children. I hope this concept is very crystal clear to you. Don't forget to hit subscribe button, like it and share it with your friend children. Thank you.